The next item that we're going to discuss is the discriminant. And the discriminant is tied with the nature of the roots. The nature of the roots just simply means type of solutions, types and number of solutions that an equation has. So the discriminant is b squared minus 4ac. Now the assumption that we're going to make in this section for sure is that a, b, and c are element of rational numbers. So you may recognize the discriminant. It is the expression underneath the square root sign, and it's really important. The discriminant tells us if a question is solvable by factoring. Question also helps us to determine if factoring is the best option. Now, if factoring is the best option, if it's not the best option, well, then we have to go on to other ideas like completing the square or quadratic formula. So the discriminant tells us if something's factorable. A discriminant also informs us of the nature of the roots. Now, the nature of the roots just simply means the number of solutions that an equation has. Quadratic equations can have 0, 1, or 2 solutions. And it tells us if we have rational or irrational solutions. So rational or irrational, and I guess all of them are real solutions. So let's take a look at the first. I find it useful if I'm going to look at this here. If the discriminant, I'm talking about this first bullet right here. If a b squared minus 4ac, if the discriminant is negative, there are no solutions. And the equation that we have is unsolvable. Now remember what we're talking about after all. We're talking about an equation. So for instance, x squared plus x plus 17 is equal to 0. This equation has no solutions. How do I know? Well, I don't. But if I check the discriminant, my discriminant would be negative. Is there a way to solve that equation? There is not. If our discriminant is equal to 0, we have one solution. So we test out the value of our discriminant. We have one solution, and the type of solution would be rational. And since it's rational, we can factor. So those two generally go hand in hand. If something's rational, we can factor. We can talk about that if you want in class. Why is that so? We can always complete the square or quadratic formula. So an example that has a one solution would be x squared plus 4x plus 4 is equal to 0. And we would have our discriminant is equal to 0 here. If you plug in those numbers, for sure you'd get the discriminant is 0. And if you were to factor it, you'd recognize that indeed that this equation has one solution at -2. And -2 is a rational number. All right. Now for the next bullet, if our discriminant is positive and not a perfect square, then we would have two solutions, and those solutions are going to be irrational. So if your discriminant is greater than 0 and not a perfect square, so what I'm trying to say maybe is that my discriminant, I'm going to highlight it here, pardon me, I'm going to highlight it right here. If my discriminant is not a perfect square, it is not a perfect square. It won't have a perfect square root. That is, there will always be an irrational component to that. So that's why your solutions are irrational. And you cannot factor it, so you have to complete the square or use the quadratic formula. Now, if your discriminant is greater than 0 and a perfect square, you have two solutions. You can factor it, and your solutions are rational. So again, if your solutions are rational, factoring's on the table for you. So what helps us out here? Well, what helps us understand this is quite simple. I'm going to use my quadratic formula. I'm going to split it up so it looks like this. And really, let's go under the first case. If my discriminant is negative, I would have the square root of a negative number. You can't have a square root of a negative number. That's why the solutions are no solutions. Now, for example, here, I'm just going to take this away. If your discriminant is equal to 0, well, if your discriminant is equal to 0, I can even make a further statement that this whole section will actually 0, and you have one solution at negative b over 2a. So now, if b squared minus 4ac is positive and not a perfect square, so really this is going to be some positive quantity. The reason why you have two solutions is that you have negative b over 2a plus this positive quantity, and then you'll have the second solution at negative b over 2a minus this positive quantity, whatever this quantity is. And since it's not a perfect square, this remains, the discriminant, the square root of the discriminant remains as an irrational number. You can't factor it. However, if it is a perfect square and your discriminant is a perfect square, that is, you can take the square root, well, you would end up with two solutions, negative b over 2a, plus or minus the square root of b squared over, or b squared minus 4ac all over 2a. Well, that square root takes care of itself, and it's a perfect square. So the square root of the discriminant right here ends up being a rational number, and your solution ends up being rational. With a few examples, I hope this helps.